Good evening. My name is Dr. Boyd, the chemist, and I am coming to you on behalf of the Transformational Education Adventure Center, which is located in McLean, Virginia, and is also known as the T Center. I'll be teaching a STEM lesson tonight. And tonight we are going to learn about non-Newtonian fluids. Here's what you'll need if you want to follow along. You'll need a bowl, or perhaps a cup, some kind of container. You'll need cornstarch, about half a cup of cornstarch, and you'll need some water, or a quarter cup of water. And that is all. All right, now as I mentioned at the beginning, our topic tonight is non-Newtonian fluids, and we're going to be making Oobleck. All right. As you can probably already see, my hands are kind of messy because I've been playing around with the cornstarch, making Oobleck before I got on air. But what is a non-Newtonian fluid? What is a non-Newtonian fluid? The term non-Newtonian comes from the name Newton. And Newton is a really important name in science. Specifically, we're talking about a gentleman called Isaac Newton, or Sir Isaac Newton. You may be familiar with Isaac Newton from the story of a man who was sitting underneath an apple tree and an apple fell from the tree, and we called it Newton's apple. So Isaac Newton is responsible for a number of really important discoveries in terms of the laws of science, specifically the area or field of physics. Today, we're going to talk about Newton's law of viscosity. Newton's law of viscosity. So Isaac Newton looked at liquids like water, and from the water, he was able to derive, from liquids like water, he was able to derive certain rules. And those rules gave an explanation as to why liquids behaved the way that they behaved. All right, and this is Newton's law of viscosity. Newton's law of viscosity. Believe it or not, Newton's law of viscosity does not describe all liquids or fluids. In fact, there are a lot of liquids that don't fall within the category of Newton's law of viscosity. All of those liquids, we call them non-Newtonian liquids or non-Newtonian fluids. Now, you may have never heard the term before, but you have certainly seen some of those liquids. A very common example of a non-Newtonian liquid or non-Newtonian fluid is ketchup. All right, most people have seen ketchup in a bottle and tried to get it out of the bottle, okay? It can be difficult, especially if it's in a glass bottle. Why is it hard to get out of the bottle? Well, the reason that ketchup is hard to get out of a bottle is because it is a non-Newtonian fluid, meaning it does not behave in the same way that the fluids Newton described behaved. Actually, ketchup inside the bottle, when it's at a resting state, it behaves like a solid. So when you tip the bottle upside down, the ketchup doesn't come out of the bottle. Why doesn't it come out of the bottle? Well, in order to get the ketchup out of the bottle, what do? We hit the bottle. We kind of smack the bottom of the bottle, or we hit the side of the bottle, and then eventually the ketchup flows out and it behaves like a liquid. All right. We call that kind of a liquid non-Newtonian, and specifically we say it's shear thinning. That means that when you apply a force to it, like hit the bottle, it goes from being a solid-like liquid into a liquid-like liquid. So it goes from behaving like a solid to behaving like a liquid. Today, we're going to make Oobleck, which is a type of slime, and it is also a non-Newtonian liquid. Unlike ketchup, which is shear thinning, Oobleck is shear thickening. What that means is in its resting state, it actually behaves like a liquid. But when you apply a force to it, it behaves like a solid. So if you hit it, it doesn't flow anymore. It actually stiffens up. So that is a shear thickening non-Newtonian fluid. And so we're gonna make some today, and hopefully you can have some fun with this. Hopefully you have what you need. Again, you need half a cup of cornstarch, you'll need a quarter cup of water, and you'll need a mixing bowl to mix it in. And we're gonna use these good old hands to mix the two. So I have my funnel with my material measured out. Cornstarch here. By the way, parents, this one does get messy. I apologize. All right, I don't know if you can really see. There you go. You can see my cornstarch is in here. And now I'm going to add some water. Measure up a quarter cup of water. Add it to the cornstarch. Now I'm gonna dig in. Now what you wanna do, and this is gonna take maybe a minute or two, is you want to make sure your cornstarch and your water have mixed as much as possible. All right, so you want to mix the two as much as possible. And I think I didn't measure out enough cornstarch, so I'm going to add more cornstarch. Again, you really want these in about a 2-to-1 ratio. If your solution is too runny, you can add a little more cornstarch like I did. If it's too thick, you can add a little more water, right? And once you get all of your liquid, all of your cornstarch wet with the water, you should be good to go. All right, so I can see now that I have made my oobleck, and I'm going to show it to you. Oh boy. There it is. All right, so you can see it's at rest. I'm not applying a force to it, and it's just running and dropping down, okay? Now, watch this. I'm going to take it and I'm going to hit it on one hand, and you can see that it will actually stiffen up, and I'll try to make a little ball out of it. Get enough of it in my hands. Oh my gosh, this is so messy. So look at this. Even though it's running when it doesn't move, I can actually roll it up into a ball. Why? Because the process of me rolling it is applying a force. And by applying this force, it actually stiffens up. All right. And that is what we call shear thickening. It behaves like a solid, but then the same solid behavior disappears the moment I don't do anything. I don't apply force to it. And so now it's just running like a liquid. All right. So this is what we call Oobleck. And Oobleck is a type of non-Newtonian fluid. All right. So with that, that is our lesson for today. I hope you enjoy it, and hope it doesn't get too messy for the parents out there, but I'm sure your kids will have lots of fun with this. All right, I will see you tomorrow at about 5:30. All right, thank you.